Okay, so we're going to get into a little bit of algebra. So if you're good with algebra, this stuff, certainly if you've taken an algebra course recently, this stuff will look familiar. So we're going to go through just a whole lesson on lines, everything that you've ever heard about lines, like graphing them and the slope and the Y-intercept and the X intercept and all of that. So much of this will look familiar. I'll go through some and then I'll ask you to go through some. Okay, a line is, like this pen that kind of goes off and it's straight and it goes in one direction. All lines are straight. Some are like that and go left and right. That's horizontal. And then you've got the vertical ones. And then you've got some with negative slopes. If the lines decrease as they're going down, as you read them from left to right, the line is going down. It's a decreasing line, and then here is an increasing line. And later on, I'm going to ask you to go to a website where you can have a little graph like this, and you move the points around a little bit, and once you get them on the two coordinates that you're interested in, then you can see the equation of the line. This obviously is rounded. This is probably 1/3 x plus 3 1/3. You can see, for example, if you get a vertical line in here, straight up and down, it's hard to get it there exactly. There we go. All right, so as soon as the x-axis or the x coordinates match 8, 6 and 8, 2.2, you have a vertical line here, and then you see the equation there. But let me go up to this other one here. This blue line is the active line here, and you can see it crosses through 2 on the y-axis. This red line here is the y-axis. And this dark blue line here is the x-axis. And then here's the line that we're graphing. So this line here, we would say, is a decreasing line, goes down. And notice that this line right here is the slope, and you can see the slope is negative. So as long as the slope is negative, that line will decrease as you read it from left to right. If the slope hits 0 right there, then you can see that the line is a horizontal line. And then if you increase the slope to make it positive, then you can see that the line increases as you read it from left to right. So we'll talk about the relationship between the sign, positive or negative, of the slope, and then the steepness, or how the line behaves. Notice I didn't move the y-intercept. This b here is the y-intercept. If I change this number, and watch how the line just goes down the y-axis. So it looks like the whole thing's going, but just focus on the y-axis here. As I move the y-intercept and go down further into the negatives, the line goes down, but the steepness of the slope doesn't change. The steepness of the line doesn't change. And then as the y-intercept gets larger, you can see that the line just kind of goes up higher and displays the equation. So I'm going to send you to this, this website here to draw some lines, only so that you can copy and paste your equation or your line into the document. So I'll give you the link to this site later on. Okay, the first way I'm going to give you primarily 2 ways to graph a line. The first is to find the intercepts. So we have 2 intercepts on a graph where the graph hits the y-axis. Here's the y-axis here, and here's the x-axis. Where the line crosses the y-axis, that's called the y-intercept. And where the line crosses the x-axis, that's called the X-intercept. And all points that fall on the y-axis have an x-coordinate equal to 0. So for example, this one here might be the point 0, 2. But what's similar about all points that fall on the y-axis is that the y-coordinate is equal to 2, or is equal to 0. So if you want to find, or excuse me, the x-intercept is equal to 0. So if you want to find the y-intercept, what we're going to do is we're going to let the x-coordinate equal 0, and then calculate the missing y. Now similarly, every point on the x-axis is some number, let's say -3, but the y-coordinate, the second coordinate, is always 0. This would be 1, 0. And then this point right here would be 2, 0. And this one would be 3, 0, and so on. But the y-coordinate is always 0. So if we want to find the x-intercept, we're going to let the y-coordinate be equal to 0 and solve for y. That's what this is saying up here. So let's take a look at how it would work on a problem. We have 2x minus 5y equals 10. And it says to use the intercepts to graph the linear equation, graph the line. A lot of times what we do is just create this table of values to keep the x's and the y's consistent. And it turns out that you can choose any x value and any y value and then calculate the missing x or y that goes with it. But we're going to use the intercepts here. So let's say we want to find the x-intercept. We're going to let the y-coordinate be 0 and put a 0 in there for the y. I'm going to take the equation now, and in place of the y, I'm going to let the y be 0. So if we substitute the value of 0 there in for y, intercepts are easy to check because when you throw in a 0 in anywhere, 0 times anything is 0, so this whole term just kind of goes away. And you get 2x equals 10. Dividing both sides by 2, you can see that the only thing that works there is 5. So x is equal to 5. Now, this gives us 1 point. The x is 5 when the y is 0. So we're going to plot that point, and that'll be 1 point. We only need 2 points to connect together to get the equation of the line. All right, so the next one, we're going to use the y-intercept. And for the y-intercept, we're going to let x equal 0. So I'm going to put a 0 over here in the x column. Start off with the same equation. But now we're going to put x equals 0. So if I put 0 in there for x, 2 times 0 is 0. So the x term goes away, leaving us with -5y equals 10. So dividing both sides by -5, you get y equals -2. All right, so I'm going to plot those 2 points, and then we're going to have the line. The first point is 5, 0. So 1, 2, 3, 4. Right there is 5, 0. And the other point is 0, -2. It's right there. And then we'll just connect them together. And there's the line that you're after. I didn't label my scale. I should do that. At least one side of it. Okay, so all of these are done in a very similar way. And I'll give you a chance to practice some of these later, but this is the intercept method. Okay, so we're going to now go into the components of the equation of the line. So the slope of the line through 2 points, and here's the first point indicated with subscripts of 1, and here's the second point using subscripts of 2. This is a pair of numbers. It's ordered. X comes first, Y comes second, always. So it's called an ordered pair. And this is an ordered pair, and we have 2 of them. And if you plot those 2, then if you want to go from one of those points to the other, you go up a little bit, and then you go to the right a little bit. The amount you go up or down is called the rise, and the amount you go left or right is called the run. And if you form a ratio, a fraction, where you have the rise number on top and the run number on the bottom, put them together, that's the definition of the slope. So the slope is a number, and it's equal to the change in y over the change in x. The number that or the variable that we often use for the slope is m. All right, so you should have these notes somewhere if you want to print them out. All right, let me go back to my picture here, and let's calculate the slope. Well, it really doesn't matter which point you call y, x1, y1, and which point you call x2, y2. You can flip them, it really doesn't matter. So in this picture, if we go from this point to this point, we go up 2. So the rise equals 2. And then we go over 1, 2, 3, 4, 5. So the run is equal to 5. And the slope is rise over run. So the rise is 2, and the run is 5, so 2/5. So the slope in this one would be 2/5. Now, you also see this formula, y2 minus y1, all over x2 minus x1. So this means you subtract the y coordinates on top. So here are the y coordinates, and we're going to subtract them on top. So let me start here with a 0. I'm going to take this y coordinate, and I'm going to subtract this y coordinate, but that y coordinate is negative, so it's going to look funny, minus a -2. And then we're going to do the x's in the same order. So this was my first point, so I'm going to take 5 and then subtract the 0. Well, you can see where rise over run comes from, because 0 minus -2 is the same thing as 0 plus 2, which is 2. And 5 minus 0 is 5. So you can see they match up. You can see the rise over run on the graph. And the reason we subtract the y coordinates is because that's what the rise is. And the reason we subtract the x coordinates is because that's what the run is. Notice that this slope here is positive. It's a positive number. Notice also that this line rises. As you read it from left to right, we say that it's an increasing line. So, increasing lines have positive slopes. Okay, here are a bunch of problems where you have 2 points. And what you're asked to do here is to calculate the slope using that slope formula from right above. This here. So let's take a look at number 12. What you might want to do is to graph the 2 points. Doesn't hurt. The more connections that you can see between these in these problems, the better you'll be. So -1, 3. There's this point right here. And 2, 4. Be about right there. So if you connect those 2 points together, you've got the equation of the line. Now, you know what the line looks like in the graph, but you don't have the equation of it. We're going to look at the equation of a line like this as well. One of the things you do notice is that this line is increasing as you read it from left to right. So it should have a positive slope. All right, so I'm going to calculate this one in 2 ways. And I'm going to do it by switching the order of the points. So the first time I do it, I'm going to use this as my first point, and in the fraction, I'm going to take the y-coordinate here and subtract the y-coordinate here. If I subtract in the same order with the x-coordinates in the bottom, I have 2 minus -1. 4 minus 3 is 1. And when you have 2 negatives like this, subtracting a number is the same thing as adding its opposite. So 2 plus 1, which is 3. So slope of 1/3. Now let's do it the other way. It's going to look different, but the answer is going to be the same. Let me start with this as my first point. So then if I subtract the y's, I get 3 minus 4. And if I subtract the x's in the same way, -1 minus 2. So what you're going to get here is -1 on top and -3 on the bottom. A negative divided by a negative is positive. So you still get the 1/3, even if you change the role of the points from point 1 to point 2. It's a positive number, and that's consistent with a line that increases. Okay, why don't you do number 20? -2, 3, and 1, 3. I always like to draw the graph because a lot of times that can tell me what's going on here. -2, 3, right there. And 1, 3 is right there. And if I connect those two together, I get this line that is neither increasing nor decreasing. This is a horizontal line. Okay, so I see a couple of answers in the chat there. It's always going to be the difference of the y-coordinates on top. So on top, we're going to subtract 3 minus 3. 3 minus 3 for the y's, and then 1 minus -2. So yes, you're going to get 0/3. And that's 0. So if you have a line that is a horizontal line like this, then the slope is going to be 0. You can think of the slope as a number that describes the steepness. So positive, more positive, more positive, 0 right here in the middle. And as you go to a decreasing line, the slope is going to be negative. All right, let's try a similar one. How about number 16? Now this one gives us a vertical line. We can see that when you just plot the 2 points and connect them together. Might not look vertical here, but straight up and down. All right, so now we're going to take 5 minus -4, and that's going to give us 9. But in the bottom, we get 3 minus 3, which is 0. Okay, so we can't divide by 0. It'd be like taking 9 objects and dividing them equally into zero groups. That can't happen. You can also see that 9 divided by 0 causes your calculator some angst there. Dividing by 0, can't do it. However, when you take 0 divided by 9, you can do that. 0 over a number, yeah, you can do that one. Right on. Number over 0, no, can't do that. So we say that if you take a number and divide by 0, that's undefined. And you get a problem there. So we will say vertical lines have undefined slopes. There's certainly legal lines to draw, right? It's just that their slope is undefined. And you'll notice that the x-coordinate of this point is 3, and the x-coordinate of this point is 3, and every other point that falls on the line is going to have an x-coordinate is equal to 3. So just for short, let's just say x is equal to 3. And this turns out to be the equation of that line, x equals 3. All right, so here's kind of a summary. If the line increases from left to right, positive slope. That's what this means. If you look at the graph and it decreases from left to right, m is less than 0. That means the slope is negative. For horizontal lines, the slope is 0. And for vertical lines, the slope is undefined. All right, now we're going to put it all together, and we're going to add the slope to one other number. And that's going to give us the equation of our line. So on this graph, they point to this point on the y-axis. That's called the y-intercept. Its y value of that point is what we're going to call b. And b actually appears in the equation of the line. The slope is m, describes the steepness. In this case, we would know m is less than 0, negative, because the line is decreasing from left to right. And this xy is just some arbitrary point on the line. And then here is the equation of the line. This is called the slope-intercept form of the equation of the line, because when you have the equation solved for y like this one, the number that's sitting in front of the x is the slope, and the number that stands over there by itself is the y-intercept. And so we call this the slope-intercept form of the equation of the line. All right, I want to go back to graphing now, and I'm going to show you, if you remember, slope is rise over run. So if you, this little blurb over here says, if you have the slope is like a number like 2, it might make more sense to write it as 2 over 1. If you write it as a fraction, then you can graph it by knowing the rise is 2 and the run is 1. 2 over 1 is 2. That's this. All right, so here's the method of graphing a line if your equation is in this form by using the slope and the y-intercept. So let me show you how this would work. I'll take number 26. It has a fraction in it. All right, so from this, if you match up the y equals mx plus b, the number in front of the x is 1/2. So the slope is 1/2. And then the number that stands out here by itself is the b. So the b is equal to 2. So let me show you how to graph this line without even identifying a single point. 1/2 x plus 2. All right, so we're going to start with the y-intercept. So we're going to graph a point at the y-intercept. We know this point is on our line, so why not graph it? So 1, 2, it's on the y-axis. Y-intercept will always be a point on the y-axis. So there's one point, and then here's how we're going to use the slope in order to find the second point. From the first point, we're going to use the definition rise over run. And the rise is 1, and the run is 2. So from this point, we're going to go up 1, and then from that point over, we're going to run 2. 1, 2, positive 2. Where we end, that's going to be another point. So rise over run. You start with the y-intercept and then go find one more point using the slope, using this rise over run idea. And then all you need to determine the equation of a line is 2 points, our 2 points. So there it is. We've got the graph. So again, the point was we're going to graph a line, and we're going to graph a line if an equation is given to us that's in slope-intercept form. If the equation is not in slope-intercept form, then we can do a little bit of algebra to make it that way. Whenever you see this f of x, that means that it's trying to give you the equation of the line in what we call function notation. And this f of x is our function notation. And you can just replace y with f of x wherever you see it. So like this one here, f of x equals negative 5/3. You could just write that y equals negative 5/3. All right, let's do number 32. We have y equals negative 4/3 x. Now there is nothing kind of hanging out over here by itself, so it must have been plus 0. So the y-intercept is equal to 0. So if we wanted to graph y equals negative 4/3 x, there's nothing out here, so the y-intercept must be 0. So we're going to start at 0. Now our slope is negative 4/3. You can put the negative sign with the top number, or you can put it with the bottom number. But what you can't do is you can't put the negative sign with both the top and the bottom, because then it would be a negative over a negative, and a negative divided by a negative is positive. And we know that our slope is negative. So you got to put the negative with the top or the bottom. And so if you use this one here, the rise is negative 4 and the run is 3. Okay, so when the rise is negative, instead of going up 4, we're going to go down 4. So 1, 2, 3, 4. And then from that point over, we're going to go a run of 1, 2, 3. And where we end up, that's our second point. So on the horizontal scale, positive numbers, you go to the right, negative numbers, you go to the left. For the y-axis, positive numbers, you go up, negative numbers, you go down. Okay, then we take our starting point and our ending point and connect them together. And there's the equation, or there's the graph of the line. The top number is the rise. So if we use this fraction instead, and we use the rise of 4, then we would want to go up, because positive numbers on the y-axis would go up. So if we started here and we wanted to use a positive 4, we would go up 1, 2, 3, 4, and then our rise would be positive 4. Whereas if we use it like this fraction and the top number is negative 4, then the rise is going to actually go down. And that's why we did this red one here. Well, if we use this one, where the rise was 4, then the run would be negative 3. So the run would be 1, 2, 3. And for the x-axis, the horizontal axis, negatives go to the left. Positives go to the right. So if I did this other fraction, then I would get this point. But when I connect them together, I still get the same line. Slope is negative, line decreases. Y-intercept and the x-intercept in this example turn out to be the same number. 0. Okay, so this one kind of takes you through some steps where you can use the, if your original equation doesn't look like this, where you have it in y equals mx plus b, you can start with an equation, use a little bit of algebra, and convert it to y equals mx plus b. So let's take a look at problems like this, like number 38. It's not in y equals mx plus b form right now, but what we can do is we can apply a little bit of algebra to this equation. To get the 3x off the left-hand side of the equal of the equation, we can subtract 3x so that the 3x is erased on the left. But whatever we do to the left, we have to do to the right. So y equals negative 3x and then plus 4. You know from algebra that negative 3x and 4 are not like terms, so there's no way to combine them if you add them together. So we just write it negative 3x plus 4. Just write both terms. Okay, so this would be part A. All right, because in part A, they wanted us to put the equation in slope-intercept form by solving for y. And that's what we did here. Part B wants us to identify the slope in the y-intercept. Well, if the equation is in the slope-intercept form, then the number that is attached to the x, that is the slope. The slope is not negative 3x. The slope is negative 3. It's just the number in front of the x. And the number that stands out here by itself is the y-intercept. So that's the value of b. So slope and y-intercept. Most of the time, we just identify the y-intercept as the b value. If you wanted to identify it as a point, just make sure you put the x coordinate is equal to 0 in there, and then the y coordinate would be 4. And that would give you a point on the y-axis. And then finally, with this one, use the slope and the y-intercept to graph the line. So we start at the y-intercept. 1, 2, 3, 4. There it is, at 4. That's going to be one of the points on our line, but there are an infinite number of lines that would go through that point, all of these. So we need another point. And to get that other point, we're going to use the slope. So this is that trick that they told you about on that other page. If the slope is an integer, such as 2, why should I express it as 2 over 1 for graphing purposes? All right. Well, because we need a top number and a bottom number so we can identify the rise and then the run. So we're going to write this as -3 over 1. And then we have the rise over the run. All right. If the rise is negative, we're going to go down. So 1, 2, 3 to there, so that the rise equals -3. And then the run is 1. That's a positive number, so we go to the right. And where we end up after doing that rise and run, that's going to be our next point. So from this point to this point, we go down 3 over 1. In problem number 3 there, or C there, you see that we're going to use the slope and the y-intercept to graph the line. So the last thing we have to do is just to connect those 2 points together. And there's your line. Negative slope, line decreases. So you'll see that connection all the time. Okay, in this next one, they give you some more information about the equation of a horizontal line and the equation of a vertical line. So for a horizontal line like this one, notice it's usually never going to cross the x-axis. So a lot of times it doesn't have any x-intercepts, and it's going to have one y-intercept. And whatever that y-intercept is, the equation is y equals the y-intercept. In this case, y equals b. So if that point was 0, 7, then the equation would be y equals 7. Vertical lines go up and down like this. Notice it has an x-intercept, but usually no y-intercept. It's not going to cross the y-axis if it goes up and down, unless the line is the y-axis itself. Then it's got an infinite number of y-intercepts. If the x-coordinate of the x-intercept is a, then every other point on this line will begin a comma something, a1, a2, a3, a -1, a -2, a -3, and so on. So the x-coordinate is a, and this is the equation of a vertical line. All right, so in some cases, you'll be given equations. You need to know the context. It says to graph each line. So if you subtract 5 from both sides on this one, you have x equals -5. X equals -5 is a vertical line. So just go over here at 1, 2, 3, 4, 5, -5, and then draw a vertical line through -5. Okay, I want to ask you to try this, and you can put your answers in the chat to this one. And let's do 57 first. You have 1, 2, 3, 4 lines up here. Try to write down what the slopes of those lines are in comparison to one another. If you were to have to identify the value of the slope, what would you say the slopes are here? Now, you don't have to get it exactly, but list the slopes. Okay, so this line here has a slope of m1. This line here has a slope of m2, because m2 is the number in front of the x. This line right here has a slope of m3, because m3 is the number in front of the x. And then finally, this line right here has a slope of m4. So if you had to order them in order of decreasing size, all right, so we'll just say in descending order, in order of decreasing size. So the smallest one, so state the largest one first and then go down from there. So you're going to have, in the chat, you're going to have a listing of M1, M2, M3, M4 in some order, according to list the first one that you're going to list is the M that has the largest slope. And then you'll list the M that has the next largest slope, and then the next largest slope, and then finally the smallest slope. The first thing that you want to observe here is that this line here and this line here are both increasing. So they're going to have positive slopes, and positive numbers are larger than negative numbers. So Then if you look at these two positive ones, you can see if you do rise over run here versus rise over run here, well, I have to keep them consistent. So if I keep the same run as this one, notice the rise is higher. So if we keep the runs the same, the rise here is higher. So this line is steeper than this one. So if the slope here was, say, 2, then this slope would have to be a little bit less than that. Maybe it's 1, or maybe it's 1/2. But they're both positive because the lines increase from left to right. So the largest one is M1, and then M3 would come next because they're positive. All right, now the last two lines decrease as you read them from left to right. Now this line right here is closer to the horizontal than this one down here. This one down here is a little steeper, and so therefore it's going to have a little bit more negative slope, higher negative slope. So if this one, we know it's negative, if it's negative, say 1/3, then this one here would be also negative, but it would be, since it's steeper, decreasing at a greater rate, it's going to be a larger number than that. So maybe it's, -2. So M2 would come next, and then finally M4 would be the largest. So if this is what you wrote, and I see that in there for many of you, some of you, that would be correct. So you're focusing on the steepness of the line. Okay, now your next problem, number 58, asks you to consider the Y-intercepts. So if you had to rank the Y-intercepts of these 4 lines in order of decreasing size, so which one has the largest Y-intercept, and then the next largest, and then the next largest? So an answer is going to be something like B1, B2, B3, and B4. So list those 4 in order from largest to smallest. And the B's are the Y-intercepts. So focus in on where each one of those lines cross the Y-axis. And yeah, go ahead and enter it into the chat. And then again, question mark if you don't know. I have lots of question marks. We'll take some time to go through it in a little bit more detail. All right, so let's just go right straight down. Here's the largest B. This is B1. And this is the next largest. Oops, it's not B1, that's B2. And then this one here is B1, because it's on this line. And then this B comes next. It's from here, B4. And then this one is the smallest Y-intercept, and that one corresponds to B3. So if you write them in order, B2, B1, B4, and B3. And I saw that a lot in the chat. All right, now the way that we interpret the slope, we're going to get, I noticed that in Newton, you're going to have a lot of applications, word problems that kind of ask you to write an equation relating the X and the Y. And these equations will be lines. And so we're going to interpret the slope as a rate of change, the rate that Y changes with respect to X. Like, how does the COVID death rate change over time? So many deaths over how many weeks? A lot of times they're interested in how long it takes for the number of deaths to double from one day to the next. So right now, the number of deaths each day in the United States is over 1,000. So at what point is that rate going to increase to, say, 2,000 deaths per day? And it will increase, unfortunately. All right, so let's take a look. There's all these different applications. Lines are the most studied and used equation graph that we have. And it's used a lot. And so in just about every application, you can pull out a straight line relationship somewhere. But here's a relationship that talks about grade inflation in US high schools. In recent decades, high school teachers have given higher and higher grades to students. The bar graph shows the percentage of A grades and C grades for high school students entering college for 2 years, back in 1968 and then in 2008. So it's a 40-year difference. And they looked at all the grades, and it says find a linear function in slope-intercept form that models the given description. Each function should model the percentage of a particular high school grade. P of X of students entering entering college X years after 1968. So year 1968, X is the number of years after 1968. So they defined this for us up here. Number of entering college X years after 1968. So in the year 1968, that represents 0 years after 1968 because it's 1968. In 2008, that would be 40 years after 1968. Percent A grades. All right. It says here in this problem that in 1968, 18% of the grades were A's. So in 1968, 18% of all grades given were A's. This was in high school. And that has increased at an average rate of about, all right, so we have this rate, which is equal to 0.725% per year. We can see from looking at the graph that the number of A grades in 2008 was 47%. So you can see quite a lot, right? High school grades, 18% of grades, A's. 1968, almost half of all grades are A's in the year 2008. Okay, now we'll come back to this. We'll see if it actually applies to our problem at all. But what we have here is we have 2 points. And I'm not going to use the year data. I'm going to use how it's coded. So we have 2 points. This point and this point. And they gave us this one. And we know that if we're going to graph a line and the x coordinate is 0, that this point right here is the y-intercept because the x coordinate is 0. So let me draw a picture of this one. I'm going to use those 2 points. I'm going to write them down here. We know the y coordinate is the percentage of A's given, and we know the x coordinate is the number of years after 1968. But we have 2 points. So y equals mx plus b is the line we're looking for. Now, they said you may have seen that p of x business in there. So if you want to write it as in function notation, you would write it as p of x, but we don't need to do that. The first thing we're going to do is we're going to calculate the slope. We know how to calculate the slope if we have 2 points. We take the difference in the y coordinates and divide that by the difference in the x coordinate. Now that number looks familiar. And the y-intercept is equal to 18 because there it is right there. If you were to graph this, you would have 0, 18, and then you would have 40, 47, and then here would be the line. But that 18, that 1 point that they give us there, that is the y-intercept. And we could only do this problem because that's what they gave us. All right, so we start with y equals mx plus b. We put in 18 for the m and the 0.725 for the b, and then 0.725 for the m. And you get this equation. And that would be percent of A's given. So here's an application. There are many, 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 many more where this is used. So they said you could call it P of X if you'd like, but there it is. And you could do a similar problem with C grades as well. Here it is. Or P of X equals 0.725 if you wanted to put it in the function notation. Now, this problem could have been much easier if it says the slope is the rate of change. And then they give us the average rate of change to be 0.725. So we could deduce the y-intercept, 18, and we're given the rate of 0.725. You saw how we got that from the graph. And you just take those 2 numbers and plug them in. Here's another. Studies show that texting while driving is as risky as driving under the influence of alcohol, 0.08 blood alcohol level, the standard for drunk driving in many states. The bar graph shows the number of fatalities in the United States involving distracted driving from 2005 to 2008. You don't see that, but you will here shortly. Here it is. Here's the bar graph that they're talking about, and then here's the scatter plot that they're talking about. Although the distracted category involves such activities as talking on cell phones, conversing with passengers, eating your lunch. Experts at the National Highway Safety Traffic Safety Administration claim that texting while driving is the clearest menace because it requires looking away from the road, where if you're eating, you can look at the road, right? If you're talking to friends, you can look at the road. But when you're texting, you're looking somewhere else. Shown to the right of the bar graph is a scatter plot with a line passing through two data points. According to the scatter plot on the right, which is down here, I'll show it to you in a minute. What is the Y-intercept? And then describe what it means. I'll magnify this a little bit. You can see it. All right. Here's the scatter plot. We're focused in over on this here. This is years after 2005. So 0 years after 2005 would be 2005. 1 year after 2005 would be 2006. So instead of just giving the year on the horizontal axis, they've coded it so that they're just giving you the number of years after 2007 and 2008. And they give you 4 points. 1, 2, 3, and 4. Notice how they go up and then over and down. Same thing over here. They give you the raw numbers. So these two graphs are showing the same information. Here's your graph. Focus in here. First question is, what is the Y-intercept? That's right. It's this is the 0, so this is the Y-axis. It's labeled even here. And so the Y-intercept is 4571. So that's going to be one number that we insert into our equation. The other part of this says describe what it represents in this situation. So the Y-intercept equals 4571. What does it mean? It's the Y value when X is equal to 0. And X equals 0 corresponds to the year 2005. So this point is 04571, which means in the year 0, which is the year 2005, there were 4,571 deaths involving distracted driving. So it's not going to be sufficient in these application problems just to say what the Y-intercept is. You have to interpret it. In 2005, there were 4,571 deaths caused by distracted driving. And that's all it says. It doesn't say anything that these distracted driving incidences were the result of texting. Well, maybe that might be what they mean. So even though it's an application, the next step says use the coordinates of the 2 points, 0, 4571, and the other one is this one here. So using the 2 points that are on the line, this one and this one. Now this one is the point 35870. All right, go ahead and calculate the slope and put your slope answer in the chat. And then we'll interpret that. In project 8 that's coming up, I ask you to interpret the Y-intercept and interpret the X-intercept. So you're going to be doing this to a different application. Here are the points. You can see that the line is increasing. That should tell you something about the slope. But what we're after here is the specific value of the slope. And we're still going to go back to our generic definition of a slope. Change in the Y coordinates all over the change in the X coordinates. Subtract the Y's over the subtraction of the X's, and you're going to get a fraction. Maybe you can reduce it. Okay, so I'm getting two things. I'm getting 433s and I'm getting some question marks. So let's take a look. We have our 2 points. You know, the coordinates are much larger than we're used to in our earlier problems, but we have to subtract the Y coordinates and put it on top. So I'll take this and then subtract this. And then on the bottom, I'm going to subtract in the same direction, but I'm going to subtract the X coordinates, 3 minus 0. So on the bottom, we have 3, and on the top, 5870 minus 4571 is 1299. And then if we divide that by 3, there's where that 433 is coming from. So you calculate the slope the same way you would regardless if the coordinates are large or small. Always the same, difference of Y's over the difference in the X's. Subtract the Y coordinates, subtract the X coordinates, put the Y difference on top and the X difference on the bottom. All right, what does this represent in terms of the rate of change? All right, so you will be asked to interpret the slope. The number on top would be the number of deaths caused by distracted driving, and the number on the bottom is the year. So if you put those two together, this number means deaths per year. So what we would say is we would say deaths are increasing at a rate of 433 deaths per year. So here's the slope. You could write that as 433 over 1. So as the years go up by 1, the deaths go up by 433. Deaths are increasing at a rate of 433 deaths per year. It's kind of rate of change. Okay, now part C says use the Y-intercept from part A and the slope from part B to write a linear function that models the number of highway fatalities involving distracted driving in the United States X years after 2005. So we start with y equals mx plus b. The slope we just calculated to be 433. The y and the x are the independent and dependent variables. They stay in the equation. And then the b value, we also identified up here to be 4571. So there's the equation that relates the year and the number of distracted, or the number of deaths caused by distracted driving. Now what we can do with this is what you're going to see in part D. And in part D, it says in 2010, surveys showed overwhelming public support to ban texting while driving. Although at the time, only 19 states and Washington, D.C. outlawed the practice. Without additional laws that penalize texting drivers, use a linear function you obtained from part C, there it is, to project the number of fatalities in the US in the year 2015. Okay, so we're going to use the equation then to make a prediction. We're going to predict the number of deaths. Notice our data here goes only from 2005 to 2008. If we wanted 2015, we'd have to go way over here somewhere. What would be the value of x that would correspond to 2015? If 0 corresponds to 2005 and 1 corresponds to 2006 and 2 corresponds to 2007, then what would correspond to 2015? What's the value of x way over here? How many years after 2005 is 2015? Okay, so that's the first thing you do, because you don't want to plug in 2015 into your x, into this equation up here, because x means the number of years after 2005. So if you put in 2015 for x here, that would mean 2015 years after 2005. So we're talking about the year 4020, and that's not what we want. Okay, so y equals 433 times 10, because the x value is 10, plus 4571. Yeah, so evaluate that, and this would be what we would expect using the same model, the number of deaths to be in 2015. So we would expect 8,901.